Hello all, welcome to Coder. Welcome to Coder. Today let us solve the lead codes daily challenge, and the problem is delete the middle node of a linked list. You are given the head of the linked list, delete the middle node and return the head of the modified linked list. And this is a quite straightforward problem. We are given a linked list. We have want to delete the middle node of the linked list. If the size of the linked list is n, then we have to delete the node which is at the position of n by 2. Middle node is nothing but at the position of n by 2. So here there is we can observe one thing that the linked list can be of size odd length as well as even length. You can see the example 1 is containing the odd number of nodes 1 2 3 4 5 6 7. So there are 7 nodes. So if we do 7 by 2, which is nothing but the 7 by 2 is nothing but 3. So we are deleting the node which is at position 3, that is 0 1 2 3. So we are deleting the position, deleting the node which is at the position 3. And similarly the even node, so even in example 2 there are 4 nodes, 4 by 2 which is nothing but 4 by 2 which is 2. So we are deleting the node which is at position 2, 0 1 2. So as you can see that we are deleting this 3. So if the node's length n is equal to 2, then we are deleting 2 by 2 which is 1. So we are deleting the node which is at position 1. So obviously what we can do is in a brute force manner we can first count the number of nodes in the linked list. Then we can find the middle node's index as n by 2, and then we can traverse to that particular node and we can have a previous pointer, and just we can change the link. Previous of next is nothing but my previous of next of next, previous of next of next. Like that we can just delete the current node. So but how can we do this in efficient? We can without traversing 2 or more times. By traversing only once, we can do this. We can delete this middle node of the linked list. How can we do? How can we do that? We can use the technique called as Hare tortoise technique. Hare tortoise technique. This is used. This technique is used to find a cycle in a linked list and so on. There are many such implementations. That technique we are going to use here. We are going to have a slow pointer and a fast pointer. Where fast pointer going to move 2 steps ahead. Fast pointer going to move 2 steps ahead. Fast of next. And slow pointer going to move 1 step ahead. Slow equal to slow of next. So by this technique we can find the middle node of the linked list. How we are doing that? If my fast pointer reaches the null, then obviously the slow pointer will be standing at the middle node of the linked list. Let us take some of the examples and check. We are given we can take the first example 1 3 4 7 1 2 6. So consider we are having the slow pointer here and the first pointer is here. First pointer of next is not null. The first pointer of next is present. So we can move here. We can move 2 steps first pointer. We can move 1 step slow pointer. We can move again the 2 steps fast pointer, and we can move one slow pointer 1 step ahead, and move the fast pointer 2 steps ahead, and slow pointer 1 step ahead. And as you can see that the fast of next is not present, so obviously the slow pointer will be at starting and we will be at the position middle node of the linked list. But to delete this particular node 7, what we have to do, we are needed is we want to need a previous node of that linked list. So to get the previous node of the linked list, what we can, so to delete the node, we need a previous pointer. So we can have a previous pointer while on the go itself. So we can just change the link. Previous of next is nothing but previous of next of next. So let us take the third example as well as, and see 1 2, and as you can see that slow pointer will be at this position, and okay, it is 2 1 2 1. Slow pointer will be at this position, fastest this position. So we are moving fast pointer 2 positions ahead, and slow pointer 1 position ahead. We will be having a previous as well. So first pointer reaches the null. So what we are doing is previous of next is nothing but previous of next of next. So we are deleted the node 1. So let us try for n is equal to 1. If there is only one node, the slow pointer will be here, the first pointer will be here, and as you can see there is no first of next of next. First of next is not first of next is null. So obviously the node to be deleted is 1, and what we can do is we can just return the return null if the head is, if there is only one node. So what we can do is we can handle the edge cases. If my head is not present, then return null, or my head of next is not present, also we can just return null. Or else I will need a fast and slow pointer. So I will have a slow pointer which is at the head, and a fast pointer which is pointing to head, and also I need a previous pointer which is at head. Let's see. While my fast is present as well as my fast of next is present, then what I will do is first I will point my previous to be slow, then my slow will move one step ahead, then my fast will move fast equal to fast of next of next. So two steps again. After coming outside this loop, previous of next is nothing but previous of next of next, and my current slow of next I can make it as null. Slow of next equal to null. I can just delete this node slow. I don't, or and then I can just return head. So now let us try to run the example test cases. Superb, it gets accepted. Let us give only one node as well. Superb, it gets accepted. So let us submit the code. Superb, it got accepted. Hope you like this solution, and let me know in the comments if there are any suggestions left. And this, the time complexity here will be order of n, and the space complexity will be order of 1, since we are not using any extra space. That's it. Bye.